Hi, this is Robert Smith from M2 Technologies, here to present Autodesk Nastran InCAD. Let's cover some basics. What is simulation? Simulation is an integral part of the digital prototyping process. Essentially, the 3D CAD model of your product is your digital prototype, the sole source of truth from which information flows to design and engineering, test and validation, manufacturing and production, and sales and marketing. Simulation takes place in the test and validation phase of the digital prototyping process. This is the phase of your process where critical questions need to get answered. Questions like, will my part break? How light can I make it? What happens when the temperature changes? These questions have traditionally been answered by building a physical prototype for testing, a costly and time-consuming process. Leveraging your digital prototype and the Autodesk simulation software portfolio, products can be tested in a virtual environment, thereby reducing or eliminating costly physical prototype iterations. Why simulate? Simulation leads to better products in less time and at lower costs. Performance can be predicted, and materials and design features can be optimized. This leads to a higher quality product. Costs can be reduced as fewer physical prototypes are needed for testing, and defects that may lead to unsatisfied customers can be uncovered while corrective action is still relatively inexpensive. Finally, innovation is fostered. Designers and engineers are free to explore more what-if scenarios, as testing these ideas digitally is more feasible than manufacturing a prototype. One of those crazy ideas may be your next big innovation. What makes Autodesk simulation different? Who uses Autodesk simulation? Autodesk simulation is built from the ground up to be fast and easy to use. Note the triangle graphic on screen. This triangle represents the entire community of engineers and designers. Traditionally, highly educated and highly specialized individuals, represented by the top portion of the triangle, have been relied upon to perform FEA analysis. These individuals are typically career analysts. They are expensive people who use expensive tools. This type of analysis is often done at the end of a design cycle for validation purposes. Autodesk simulation is part of a newer approach to simulation, called upfront simulation. It's for the everyday engineer or designer. These individuals often wear many hats, and running analysis software may only be a part-time role. They need results early in the design process to help them make more informed decisions while the product is still in development. For this reason, they need the tool to be easy to learn and easy to use. Autodesk simulation serves these users. Let's compare the traditional design process with the digital prototyping design process. In the traditional design process, the initial concept is developed using a combination of past experience, hand calculations, and educated guesses. Using this method, it is not unusual for the first physical prototype of that design to fail. This results in the need for another iteration of the process, which means more design time and another physical prototype build. Each iteration of this loop adds cost to the process and increases the time it takes to get to manufacturing and to market. When a design does pass physical testing, there is little confidence that the design is optimized. It did not fail, but is it over-designed? In contrast, the digital prototyping method uses virtual testing to eliminate failed designs before a physical prototype is constructed. Initial concepts may fail to meet requirements, but iterating digitally is far less time-consuming and costly than iterating physically. In fact, iterating the design is so efficient with digital prototyping that the designer can afford to continue iterating even when the design has passed, in the search for a design that not only works, but is of the highest quality and lowest cost. New innovations can take shape, and better products are the result. All of this before the first physical prototype is constructed. What is Nastran? Nastran is a general-purpose FEA, or finite element analysis, solver. In the 1960s, NASA developed Nastran in an effort to standardize FEA solver codes, which were then in their infancy. The result was the code that NASA used to bring the U.S. to the leading edge of the space age. NASA released this code into the public domain, where it has since evolved and is now the basis of some of the industry's finest and most respected FEA software platforms, including Autodesk Nastran. Autodesk Nastran is proven and credible, providing accurate results for advanced linear, nonlinear, dynamics, and heat transfer analyses. It is scalable in that it is compatible with a large number of specialized third-party pre- and post-processors. What is Nastran InCAD? Autodesk Nastran InCAD is the power of the Nastran solver embedded in your CAD system. Available for multiple CAD platforms as a networked license, the CAD environment that designers and engineers are already familiar with then becomes the pre-processor for setting up simulations and the post-processor for reviewing results. This eliminates the need for a standalone simulation software package. Autodesk Nastran InCAD supports a wide array of analysis types. Linear static stress in normal modes are commonly found in embedded simulation systems. Nastran InCAD takes it to the next level with advanced nonlinear, static and transient stress, dynamic response, and thermal analysis types. Let's look at some quick examples. Now let's take a deeper dive into a full demonstration.
Welcome to this demonstration of Nastran InCAD-driven design. Briggs Automotive Company is dedicated to the safety of their vehicles while reducing as much weight as possible from the parts they make. Let's take a look at this pedal box assembly and continue the design process for the clutch rest on the left. These components are a concern due to the large force during normal operation. At times, the magnitude is the entire weight of the driver. In an effort to reduce physical prototypes, we'll find out if the current design for the sheet metal is safe. Watch how this is done using Nastran InCAD without leaving the familiar inventor interface. We'll begin by holding the cylinder mount down to the pedal box base. Each of the boundary conditions provide great visual feedback for the type and location. Next, we'll apply the load to the clutch rest. Our goal is to withstand a force of at least 600 newtons, or about 135 pounds. We can also use bolt connections to simulate how the two parts are held together. Nastran InCAD calculates the material, preload, and type using a threaded or nut and washer condition. Use the calculated results to gain insight for axial force and shear on each fastener. Will the bolt shear? Do we need more? What are the optimal locations for each of them? Contact conditions also assist in gaining high-fidelity results. Here we have a weld between the two sheet metal flanges. Since the weld wasn't modeled, we'll simply choose the faces that are bonded to each other. Let's go ahead and mesh the part and run the study. The question is, will the part fail under this load? The first thing we're looking for is stress, and we can see that the clutch rest is not going to yield under this load. That's great, but is the linear static study telling the entire story? It's not taking into account that the part could lose stiffness. Is it possible that the clutch rest could buckle before it yields? We should take this into account and copy the existing study so we can keep all the same boundary conditions. And we'll start with the linear buckling type. We'll change the load to a value of 1 because the results will tell us the maximum load for various ways the design can buckle. Linear buckling studies run very fast and provide insight into whether we should be concerned with buckling failure. We can see the maximum load is 633 newtons, which meets our criteria by a small margin. It would be a good idea to run this as a nonlinear buckling type. This study takes more time to solve, but when it's finished, it will provide highly accurate results. We'll use a load that's beyond 633 newtons, and Nastran InCAD will tell us when or if it buckles before it reaches the full load. Nonlinear studies apply the load in increments, which is great for high fidelity. Now that the study is finished, let's take a look at the graph for the load factor versus displacement. We can see that the part does fail, and exactly when it fails at 65% of the load, or 522 newtons. We wouldn't have known this with just a linear static option included with Inventor Professional. Let's play an animation to find out how it buckles and use this information to make an informed design improvement. Now that we know where the problem area is, we can immediately begin the 3D modeling process. We never left the CAD design environment. By adding a small flange in the bottom, we can greatly increase the stiffness of the clutch rest in the direction of the load. Inventor makes this easy with powerful capabilities working with sheet metal and the ability to model and refer to other components within the context of the assembly. Let's update the mesh and rerun the analysis. We can see in the graph the model is moving, but no longer buckling. Once again, let's show an animation to fully understand the behavior of the displacement. There is some movement in the Z direction, which is taken care of by the clutch stop. We have successfully designed a better clutch rest using the powerful solving capabilities in Autodesk Nastran fully embedded in the CAD design environment. High-end analysis such as nonlinear, dynamic response, fatigue, and thermal heat transfer can be accomplished in the familiar Inventor interface. As you have seen, Autodesk is your trusted solution for the future of making things.
Who is M2 Technologies? M2 Technologies is the leading manufacturing design solutions provider in the Northeast, providing services such as training, consulting, and project shadowing. We are a simulation-specialized Autodesk Gold partner, as well as an Autodesk authorized training center. We have a deep roster of talented technical specialists with expertise in design, data management, CAM, and simulation tools. We have several locations throughout the Northeast, but we provide services all across the USA. Thank you for your time today.